Continuing on 141. Spinning designs with loops. You can consider a loop as repeating a set number of times. For example, you may want to draw 5 circles, so you can set a loop to create a circle 5 times. What does this code do? Oh, I guess I should have examined it first. Oh, well, I cheated. Okay, so let's pretend I didn't run it. I would look at this code and say, oh, it sets the color to salmon. That's a color now. Font size, speed, spiral space is 0. Okay, while this is, so it loops 80 times, it looks like that. Starts at 0 and it goes up 1 every time. And it looks like it's spiraling, but it's got this spiral space times 3 thing. I'm like, oh, what does that do? It looks like a number that starts at 0 and then it adds 1 every time, so it should get bigger and bigger. And then it's doing the rotating, just like we did in the code above, rotated between salmon and turquoise. Are those new colors? Or navy. Is that a new color for me? Ooh. Is that a new color? This is getting slower and slower. There are so many commands. Where do I put colors? Where do I put my colors? Salmon. Oh, we got a navy. Let's add navy to this. Navy. Jeez, everything's lagging so much. All right. So what happens when I run it? It's still rotating colors like above. But you might notice it here. Okay. So instead of just, it changes the colors as it spirals, but it's getting bigger and bigger as I go out. So that's probably what this spiral space is doing. Every time I iterate or go, to the next circle, it doesn't just draw the circle. It spaces it out more. It moves more forward. And I'm guessing that makes it spiral like that. That's kind of cool. Huh. What do I observe? What should I observe? Design spirals outward from the middle. So instead of just doing a circle in the middle, rotating colors, it's spiraling out. Modify the program to meet the criteria. Every 5th and 10th circle changes color. Spiral is tighter. So to make it every 5th and 10th, I just got to change these numbers. These make it every 18th and 36th. 5th and 10th. Right? Should just work. Let's see if that works. Yeah. Well, there we go. Okay, that's a pretty easy change. 5th and 10th right there. The spiral is tighter. Circles are closer together and fills the screen without going off screen or overlapping. Okay, so to make these tighter, I'm thinking I gotta make this, instead of going times 3, make it times 2. Because then it wouldn't spiral out as much, right? Well, that's my thought, because that's the only thing that's changing the spirals. Okay. Cool. Spiral is tighter and fills the screen without going off screen or overlapping. And fills the screen without going off screen or overlapping. Okay, well, it didn't really go off screen. What if I made this times 1.5? Does that work, actually? Let's see. Okay, even tighter. Okay, that's cool. Was it doing 1.5 or is it just doing times 1? It might be just doing times 1. See with that. Is that tighter? Oh, it's even tighter. Oh, that's cool. It's like barely overlapping, but it's pretty much not. That's kind of neat because it just spirals out. There you go. Cool. So you had to change basically this value right here times 3 made it go out a lot. If I go to like, can I do like point? What if I did 0.5? Just playing with things. Does it make it like super tight? Oh yeah, it does, but it's spiraling a little bit out. You can kind of tell, but everything's overlapping. Okay, cool. Well, that's good to know. Nested while loops. Okay, so this is a big thing right here. You've done while loops in this class, but this is another way to run while loops. There'll be times when you want to do more complex algorithms that involve not only repeated steps as your spiral graph, but a repetition of repeated steps. So you repeat things, but you repeat things in a repeated thing. You place a loop inside another loop to create a powerful algorithms. So that's what we're doing. A loop inside of another loop to create powerful algorithms that perform many tasks in a small, concise amount of code. Loop within another loop is called a nested loop or a nested iteration. So I'm going to write that in my vocabulary here. It's linked in my Python commands. I know I haven't updated a lot of other things. I'll do that later. I'm going to call this a nested loop. Oh, I wish this wasn't so slow. Too many things on this computer. This is, so what did they call this? A loop within another loop used with while loops. See if that typed. Oh man, look how slow that is. Okay, I can't keep typing here. So nested loops can look like outer loop and then tab in for the inner loop. For example, observing pseudocode, so like a while loop, where while j is the outer loop and while I is the inner loop, you have while j, then it increments j, so adds 1 to it. And then inside, so this is indented at the same level as the increment, while I, and then you increment again, so it's, or you indent, excuse me. These are indents. Same level, and then these mean they're inside the I loop right here. Each time the outer loop j iterates once, the inner loop runs to completion. So every time this runs once or iterates, this whole loop will run the whole thing. Now, so here's an example. We ran this code. I think I ran it earlier. Let's just run it again. So what's happening here? We got j and then I. So try to predict what the output of nested loops. Oh, I wanted to predict. I always just hit run instead. Why do they even ask me to predict? I just hit run. I don't wait. So what's going on here? So we have the outer loop j. It's going to run. So outer loop j runs 10 times. And then it increments. Oh, so they threw this new notation into you. Okay. You know how we usually would say j equals j plus 1? And that means add 1 to j. Well, there's a shortcut. You can do j plus minus 1. So this is these two lines, 4 and 5, mean the exact same thing. So I'm going to put this in my list of Python commands. Because that's... So they just threw that in there to you guys? Don't even say, like, hey, surprise. They just throw it in there. They don't even explain it. Come on, Project Lead the Way. Okay. Okay. So j plus equal. This is going really slow. Hold on. I got to pause because I'm getting mad. Oh, wait. All right. So I wrote it in here. So count plus equals 1. It's the same thing as doing count equals count plus 1. It's a way to shorthand it. So you don't have to use that, but there it is. All right. It works with minus, like if you want to subtract things. Minus equals does the same thing. So outer loop runs 10 times. The inner loop, I, runs 5 times per j iteration. I might say that. So that's what's happening. So one thing, if you look at the outputs, okay, j runs the first time, then I runs 1, 2, 3, 4, 5 times. And then j runs the second time, I goes 1, 2, 3, 4, 5. J is the third time, 1, 2, 3, 4, 5. Every time, like I gets reset here, and then I goes up. So j will run 10 times, and I runs 5 times. So because of this, I could say j runs 10 times total, but I runs 10 times 5, 50 times total. I mean, it ran 50 times overall because it's going 1, 2, 3, 4, 5. So that's what it's going on here. Oh, it says this. So that's it. Observe this while loop. Let's do this one. Okay, so let's try to predict the output this time. Painter, circle, shape. Okay, hide turtle, whatever. Starts at this while x is less than 200. Okay, it's negative 200. Adds 50. Sets the y to 200, and then it stamps a red dot. So it goes to this position xy and stamps red. And then it keeps doing this. So my guess is you start at negative 200, and then you're shifting the x values over 50, which means you're going to go to the right a little bit. And then you keep doing a red dot. So it's like boom, 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 boom. It's going to keep hitting red dots. How many will it do? Let's see. I don't know. Adds 50 every time you stay negative 200 to positive 200. How many is that? Let's find out. Okay, that's what it did. So boom, negative 200, boom. So this would be like negative 150. This would be negative 100, negative 50, 100. Okay, so if that's negative 200, oh, it doesn't even start negative 200 because it moves over. Negative 200 would be like right here. It moves over 50. That's negative 150, negative 100, negative 50, 0, 50, 100, 150. And then it probably stamps one more, but that's off screen. I wonder if I did a full view. Come on, or if it's just too small. Sometimes I think it's just too small in there. Yeah, I still only see 7 dots. Okay, I think there's one other off screen though. Recreate this program. So nested loops 2. And okay, it says Visual Studio Code. Don't worry about doing that. Just we're going to keep it in here. Add the following code. We're going to do it in here, or I can do it right in here. Code, don't worry about it. Find code as an inner nested loop and predict the output. So we're going to copy this code. And an inner, that means we're going to do it right here. Make sure this lines up. So remember when did you see as I pasted? Say, oh, I want to do it inside. And I paste, I go paste right here. Okay, this while loop is not inside. This while loop is outside. So I actually ran this right now. I don't even know what it does. Yeah, it gets messed up. It's actually printing off screen. So this, make sure this tab, right, you tab this right here. So this while loop lines up here, okay? And now, what do you think that's going to do? Well, each time I had those red dots, boom, 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 it's going to paint these blue dots. Looks like they go down 50 each time. So I'm assuming blue dots going down. How many is it going to print? I don't know. Oh, there it goes. Okay. Boom, 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 boom. There we go. Okay. So I was right. And stamps blue dots going down. All right. So I did that code. If you wanted to see that, that's what I did. Pasted it right here. All right. So there's a nested while loop with the code. Got it. Copy your nested loop program to a new file. Modify this algorithm so that the nested loop stamps the turtle using new colors in a left to right pattern instead of top to bottom as shown here. The purple stamps represent the outer loop, the orange stamps the inner. Recall you can use Painter Speed 0 to speed up your drawing. Okay, so I'm going to try doing this. So instead of going top down, we're going to change our code. Now, one way to do this is we just have to like change the X and the Y values. Yeah, the easy way of doing this? What if I just so to change X and Y values, because I want this outer loop, instead of changing the X values on the outer, I wanted to change the Y values on the outer. And the inner loop should be changing the X values, so I want to go this way. So I'm just gonna What if I just swap the place of all these? What if I just did this? I'm just cheating. If you just swapped all these. See if it works. I don't know. Might. Okay, it kind of worked. So, how many? Where's the red? So one of the problems is this. This is red. I think it's off screen over here. Because it starts at x equals 200. So this is a bad. I'm going to go 150. 200 is actually off the screen. They kind of messed up there. There we go. Okay, and if you want it to, it's only doing 3 dots now. I want it, oh, but I don't want it to go, okay, so it's not doing this perfectly. It's going the other direction. So I want it to, do the opposite. I want it to start the red over here and go red dot, blue, 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 blue. Red dot, blue, blue, blue. Right? Okay, so I got to start the red over on the other side of x. I'm going to say I got to flip. Instead of start at 150, negative 150. I'm going to be adding 50 each time. See what that does. Okay. Now, the problem is this never did a thing. So when I said plus 150, but it starts up, oh. Okay, so this loop's not even going at all because it's already greater than 0. That's never true. I want to say less than 0, I think. Let's see what this does. There we go. Okay, I flipped it. And now if I wanted to do another one, let's say less than, I don't know, 100. You can just say less than 200. I don't care. So that'll go out farther. There we go. All right, so I flipped a few things around. All right, so there I go. If you want to change these colors, this can be purple. This can be yellow or orange. I'm just call it orange. Oh, I was supposed to order. Oh no. Okay, cool. But and we're back. Step 15. Here. Oh, I don't. Oh, my regular picture in Zoom's gonna be laggy, so I'm turning it off. Nah, you can deal with it. It slows down my other picture. Yeah, that's better. All right, you're not gonna see my face. Doesn't matter. All right, so observe another example of nested loops. Predict the sketch, what this algorithm does. So let's look this over. I haven't hit play yet. So, okay, we got this. This is going to start at negative 200, 0, which should be about like left side in the middle. X and Y move as 1, while X is less than 0, while Y is less than 0. X moves a little bit, 1, Y moves a little bit, and Painter goes to this. And then it sets the move Y to negative 1. So this loops for a bunch, and then changes that. And then this loops for a bunch, but changes it to negative 1 and moves it back to 1. I don't really know. Now this go-to should be drawing like a line or something, so I'm going to hit play and see what it does. Okay. Oh, spoilers down here, right? So what's going on here is it's going up 1, 1 every time. So you start right here and go up 1 over 1, up 1 over 1 every time. So and then it gets to this where it does it 100 times. And then it changes it to negative 1. So it goes over 1, down 1, over 1, down 1, 100 times. Got it. So it does that, it's done. Okay. recreate it in Visual Code. Well, run it. So I saw that it was moving. I didn't see that it was moving like this, but that makes sense. Moves up one on X and Y axis, boom, boom, boom. Then it moves up one on X, which moves it right, but down one on Y, which moves it down. Okay. Modify the condition of the outer loop so the turtle drawing has 2 peaks as shown instead of 1. No other code, change the code needs to be made. Okay. We want to have condition in the outer loop has 2 peaks. So we just want to modify this one, right? Oh, we wanted to have 2 peaks, so I want to go bleh, bleh. Oh, come on, don't hit disconnect. So what it wants to do, it wants to go burp, 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 burp. So I want to do that. Huh. Well, how would I do that? If I did like, what if I did less than, I know it's negative 200. What if I did this? What does this do? I don't know. I'm kind of curious. Oh, no. You know what I want to do? I want it to do not boop, 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 boop. I want to go boop, 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 boop. So it stopped at 100. It stopped at 0. Right? That means you just did this once. It always just did this once anyway because the X kept going up. But I wanted to keep going, so let's make it 200. Keep going. Just got to keep that X going to the left, to the right. Yeah. Uh-huh. There we go. All done. So the way I made that happen is I knew I just wanted to keep going to the right a little bit more. So that was just, this is my X position, how they set this code up. And I said, hey, just keep going for a little bit more. Just doubled it, basically. Instead of going only 200, now it moves 400 spaces. Modify the condition in the outer loop so the turtle... Okay, I did that. Hint. Experiment with the value in the while condition that compares to X. That's what I did. Okay. All right. Write another nested loop after the first one so that the turtle draws an additional pattern that is the opposite of the original pattern as shown. Okay, so we want to write another nested loop after the first one. So what I'm going to do is take this code and repeat it. So I copy and paste. And I want it to go doot, 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 doot. But then I wanted to then go, so doot, 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 doot. And then go back here and go, just like that. So this second loop, I'm going to have to modify it. So I come back here to start. So let's just play it right now. As is. I copied it, so it's there a second time. So it's doot, 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 doot. And then the second loop should go. I want it to go, and I also, so it's weird if this is not zoomed out right. There, you can see it better now. I don't want this line too. Oh, so I better move that line, huh? Okay, one thing I want to do, I'm going to put a pen up. Wait. Painter.pen up. Painter.go to, we're going to go to X, comma, Y. And then painter.pen down. I don't want that line. So I want it to move over there right after that. So let's end that first. Then boom, and then, okay, so it's repeating, but I don't want it to do this repeat. So I want it to go down first, then up. So how do I do this? Well, right now, the Y is going up first because it's positive 1. If I want to go down first, make it negative 1. See what it does. Oh, yeah. So you want to make it go back up. So make that positive one. Okay. Uh-huh. Okay. Down. Hello? 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 No? Oh, yeah, that should have fixed it, shouldn't have? Oh. So, one of the things, y starts at 0. So, while y is less than that. Oh, the reason it keeps going down forever and it never stops is because y is always less than 0. Just keeps going down. So we don't want to say less than 0. We want to say, well, greater than, say, negative 100. That's what I should have changed. So it starts at 0 and keeps going down. I don't want to keep going down forever. And then it stops. Okay. All right. So I fixed this loop. I changed that to positive 1. While y, okay, this is going to be false right away. You want to see it while y is, I think, less than 0. Because we want it to keep going till it gets to here, till y gets to 0. So once we want to do this until it gets back to 0. I think that'll work. Okay, better. Then it goes to Narnia. Okay, so our problem here is it moved y. Remember, we have to swap this as well. Okay, so we have to swap it back to negative 1. Got it. Hello, Amir's mom. Yes, good. All right. Hey, there we go. So, recap. A few things I had to do. When it asks you and this was step 19. So yes, if you want to for your lesson, you can copy that code and just do something else to it. I don't know, make it look a little different. Oh, really? Oh, you want to make the turtle draw forever. Spoilers, I'm on 18 still. So, experiment with the values of x, y, move. Okay, so that's what we did. We had to first, we copied this while loop. And, oh yeah. And then I copied and I pasted right here. The first thing I did is I didn't want that line as the cursor goes back here. Didn't want that line to be across. So I did a pen up, pen down with the go-to move to negative 200, 0. What's a little bit annoying is negative 200 is actually off of this. That's annoying, but oh well. I wish it wasn't off the page. Like, why does this not go to 200? But, project lead the way. Come on. Come on. Okay. So I did this. And then to make it go down and then up, I had to switch the y's. Basically swap all the y's from negatives ones to positive ones and positive ones to negative ones. That was one thing. But then I realized, but just by switching those, it changes this logic right here. So I then needed to change this logic. So instead of saying, well, y is less than 100, because this is 100 here. 100's this up here. I'm going to say, well, y is greater than negative 100. We want it to keep going. Because as long as y is higher than negative 100, it's down here. And we also switch this logic in the bottom. Instead of, well, y is greater than 0, you got to say y is less than 0 because we want to go up to 0. So we had to fix those logic problems right there too. And also fixing the numbers. So that's the kind of stuff to watch out for in your code. Now it took me a little bit of time to debug because I thought other problems were happening first when it kept going down. I didn't realize it was repeating forever. So good stuff to check. And that's where programming gets hard because it's not very obvious right away where your issues are. All right, now let's go to 19. Place both nested loops in one outer infinite loop so the turtle draws forever. Okay, so if you want something to keep drawing forever, and I looked at spoilers already. I was talking about this earlier in the video. Or last video I was talking about this. So what I'm going to do is we need to make another while loop on the outside of everything. So a third. Yes, you can have a while loop in a while loop in a while loop. So here's the thing. If you want a loop just to loop forever, you go while true. While true, this will always be true. It'll just loop forever. But your other problem, if I just hit play right here, watch what happens. Actually, nothing's, I think it's going to give me an error. Yeah. So the problem is there's nothing inside of this while loop, and these all things are supposed to be inside this true loop. So I have to tab all these like this. I have to indent them all. But you look at that like, oh man, that's a lot of lines to indent. I want to show you a hint. Highlight all these lines at the same time, and then hit the tab button on your screen one time. And it indents everything that you highlighted. Now everything is inside this one humongous while loop. So let's see what it does. It's going to repeat forever. Oh, but it does that line. I don't like that. Okay. So I'm actually... Oh. Here. I can just do it this way. I can make these lines go indented too. Get the pen up, pen down thing again. Come on. And there you go. And then it should just keep repeating. And it'll keep repeating forever. But I don't want to wait for it. All right, that's through step 19. I'm going to keep going. A 30-minute video. I'm almost done. Oh, almost done here. Below is an example of expressing an algorithm that uses iteration without using a program language. Here's the flowchart used. So let's follow the flowchart. Line equals 0, put your pen down, draw a circle of 5, lift up your pen, go forward 20, line equals line plus 1. Is the line less than 5? Yes, then you loop again. Pen down, draw a circle, pen up, forward 20. Is it still less than 5? Yep. 10 down, draw a circle. So what you see going on there, if you kind of walk through it, line 0, pen down, draw a circle, go forward. Line is now 2, pen up, do it again. Down, circle, So it looks like this is going to happen 5 times. Oh, yeah, that's the one we did earlier to avoid 0 iteration and draw 5 circles. Yep. Cool. All right. Draw your own flowchart. I think I didn't care for it for this lesson because we don't talk these algorithms too much. But if you remember, like, one of the early lessons. Oh, my bad. I hit the pause button. I hit the pause button. Flowcharts. I got this thingy right here. Thingy. Oh, you can't even see it. Hold on. Zoom crowd at home. I got this thingy. You hit the side. On. Sometimes you just tap it accidentally. I probably do that a lot, and a lot of people don't say anything. Thank you, people at home. I'm going to stop this video right here. Don't forget to like and subscribe. Follow me on YouTube, on Twitch, and, help me get partner. Thank you.